Now let us first write it down all forces and moments, and then we will define the variables required and constant required to solve those equations of motion. So first equations of motion, in the equations of motion, first forces and moments are the inertial forces and moments. So the inertial forces and moments are defined as, I have typed all the equations of motion of inertial forces and moments one by one over here in this vector form from the reference paper we have showed, and this is how tau I is defined and estimated. Now we need to have some variables such as ixx, iyy, izz. These are the variables or constant for the airships. We need these values, so we'll define the required constant in the above sides. So I am actually now writing all the constant required over here in this section, which will be used by these inertial forces. So the constants are, the very basic constants are the acceleration due to gravity, and then we have the mass of the airship. In our case, Skyship 500 is the airship, and for which the mass is around 5,942 kilograms. Then the volume of the airship is 5,153 meter cube. And then we have from the reference page 40, as I showed you the reference, the page 40, the x and y location of center of buoyancy, which is in our case origin, that is why it is 0 0. And then we have the location of center of gravity with respect to origin of the vehicle, which is buoyancy, center of buoyancy, and this is what it is given over here. Now based on this, the vector is calculated, the rgx vector, rgmx vector, and this is the difference between center of gravity and center of buoyancy location. Now on other hand, we also have the physical characteristic of the vehicle. Length of the airship is around 52 meters, and then the maximum diameter is around 14 meters, which you can directly use in your program. And then we have the radius, which is basically the hull length from the center of line to root of the fin. And then we have the b, which is the fin length, total fin length. So we'll have both of them, and then delta is basically elevator deflection. At trim condition it is 0. Then aspect ratio is estimated, and it is around 0.54. Now how to estimate this eta functions, which I was showing in the previous video using the graphs. To estimate this, we'll have another video for estimating the eta variables, which is k1, k2 and k dash variables. It will easily estimate from these parameters. Now we also estimate this eta d. These are the required variables. We directly have to copy paste these things, and how these values are coming, I will provide this description in a single video for you, where you can watch and estimate this k eta parameter, and this k eta parameter basically give all these required variables. Now another constants are the inertias of the airship, which is x, y and z direction, as well as in the xy, xz and yz direction. So these are all the things. So these are the all constant we need in our case, and these constants you can directly use, or you can collect for your vehicle and put it over here, and based on this your dynamic response will come. Now after defining these constants over here, we can directly estimate these inertial forces and moments.